Hopefully you've had an opportunity to try this practice problem where we are looking at identifying acids from a list of molecules below. I'm now going to walk through the solution. So for a lot of these, we don't even need to draw a Lewis dot structure to determine if they are an acid or not. So once I recognize that I need an acid, I can come back to my definition of what an acid is. These have a hydrogen that can be donated. And it'll donate it as a proton, as H plus or H3O plus in water. So if we look at this list of molecules and we know that no matter what, we have to have that hydrogen, we can eliminate any molecules that do not have a hydrogen atom. They cannot be acids without the hydrogen. So going down my list, I see Br2 has no hydrogen in it, automatically not an acid. Aluminum trichloride, also no hydrogen, not an acid. NO2 minus, no hydrogen. And that's it. So I was able to eliminate 3 immediately. Now I'm going to look at the rest of them. So first off, I have HBr. This has a hydrogen bonded to a halogen. And that is a bond that can definitely break. And so this will be an acid. This is actually an extremely strong acid. All right, going down our list. Now we have HNO2. This is a nitrogen bonded to 2 oxygens. And a hydrogen bonded to the oxygen. So we're looking at a hydrogen that we have that's bonded to an oxygen, which we know that OH bonds can be broken by bases. So this is going to be a good acid. And even if I was looking at this and I didn't know this structure right here, I'm seeing a hydrogen atom that's either bonded to a nitrogen or oxygen. Both of these are more electronegative than it. It's likely I'll be able to break the bond between them. So this will be one of our acids. CHO2H. Okay, well there's 2 hydrogens here. So it might be an acid. And here is a little hint. Having a hydrogen that follows an oxygen is a way of saying that there's an oxygen-hydrogen bond in this molecule. And so it's the chemical formula is trying to tell us, the reader, that this is an acid, rather than including it with this hydrogen here as H2. So this one is an acid as well. And here's what it looks like. So again, we have this motif where we have an oxygen and hydrogen bonded together, and this is the bond that can break. So here I have an acidic hydrogen. Now, what about this hydrogen right here bonded to the carbon? Well, carbon-hydrogen bonds are pretty strong, and there's no electronegativity difference, so this is not a partially positive hydrogen. So this is not necessarily as acidic. The primary acidic hydrogen is the one bonded to the oxygen. All right, let's look at one more. C6H6. Well, we have 6 hydrogens. So while there is a hydrogen, which means it could technically be an acid, this one's actually not an acid. These hydrogens are all bonded to carbons. They have very strong bonds with one another. There we go. And they're not an electronegative. There's not an electronegativity difference that's significant between them. So these are all bonds that will be hard to break. And so we don't consider this an acid. It can be forced to break this bond right here under more extreme conditions, of course.